Hey everyone, welcome to the first community event of 2024. We are going to talk about testing ElastiCache and MemoryDB and empowering cloud learning with LocalStack. I'm super excited for this. I would love to know that where are you plugging in from? So maybe just put that in the YouTube comments, drop hi and just let us know where are you plugging in. So a little bit about me. I am a DevRel engineer at LocalStack and I'm going to moderate today's event. So, with that, let's begin. Today's agenda is we are going to do the introduction and welcome. Then we have a talk Local Stack 3.1. We are going to know that what's new in Local Stack 3.1, what are the different features, and we are going to know about the reworking of our internal Redis setup for ElastiCache and MemoryDB. And then we are going to have empowering community, cloud learning with LocalStack. We are going to have a community builder who is going to share his experience of using LocalStack. And we are going to have Q&A in between. So with that, let me just introduce the speakers. We have Thomas, who is the co-founder and head of engineering at LocalStack. We have Silvio, who is the software engineer at LocalStack. And we have Chiche, who is network and system engineer and AWS community builder. Thank you so much, everyone, for your time. And if you have any questions, you can join slido.com and you can use the code which you can see on the screen. We can also paste the same code in the YouTube section, the YouTube comment section. So feel free to ask any questions or maybe use the YouTube comments if you have any questions. Also, a great news that we are celebrating 50,000 GitHub stars. This is big because it has been 7 years and we have major 3 releases. And this is all possible because of the community, the contribution and feedback. So thank you so much, everyone. So let's begin with this. We have Thomas. I'm just going to hand it over to Thomas. Tell us about what's new in LocalStack 3.1.
Thanks so much, Nancy, and thanks for sharing the milestone also. This is really an incredible how far we've come with LocalStack. You know, project started in 2016, and now this is started as a small open source project, and now there's a company, and we've published our third major release, and now we've in the new year released 3.1. So it's my great privilege also to always be up here and present the work that the team has been doing and putting in a lot of effort into this. So yeah, let's dive into 3.1 and what's been happening since the last major release last year. So yeah, you can find a full list of changes on our GitHub page or on our Discuss. You can find the release tag 3.1 in GitHub and just take a look at the changelog there. And I'm going to quickly run through some of the major changes that we made. So we did a big push on GitHub issues. So I think we closed roughly 70 GitHub issues in our GitHub issue tracker. So those were some residual bugs from 3.0, but also just cleaning up the backlog, fixing a lot of remaining open issues. So if you've had trouble with LocalStack in the past with some particular thing in your service, please give 3.1 a try. There's a big chance we actually fixed one of the issues that you've had. But going through like a bit of the highlights, so starting off with some additional AWS mocks. You know, as you maybe know, in LocalStack, we like to distinguish between mocking and emulation, where mocking is really, you can interact with the API and you may have some stateful APIs, but there's no real magic happening in the background. It's just the API, you get the API responses. And we often start off new services as mocks and specifically just for create, read, update, delete operations. So we added 5 new services to our mocking suite in LocalStack, which include web application firewall, ECM, PCA, identity store, account management, and managed blockchain. So if you're looking into playing around with these services, give them a go. Orthogonal to that, we've added several new resource browsers. So we've been doing a big push in our LocalStack web app to provide a UI experience that's coherent with the features that we support in localstack. So we're constantly adding resource browsers to services that we have in localstack, and we're slowly nearing completion. So soon we'll have a full coverage of resource browsers in our web app that covers the services we have in localstack. And now we added 3 additional ones, which include OpenSearch, CloudFront, and application autoscaling. So you can sign up for applocalstack.cloud, and if you get a subscription for the paid product, you can use the resource browser to manage your resources directly from the UI. There are a few smaller enhancements to services that I want to go through. One is the EC2 instance metadata service. So this has been an open challenge. Kudos also to the team for figuring out how to do this. The instance metadata service is a well-known IP address that you can access from within EC2 VMs. So we've made this IP address available. You can call it and get metadata categories, a limited set of metadata categories for EC2 instances right now. So if you're looking for particular metadata fields that you're missing, please go to GitHub, file a GitHub issue, and we can look into adding them. Another feature for a different service we added is DynamoDB time to live. So DynamoDB time to live gives you a way to control the expiration date of particular records. So in DynamoDB, you can set a time to live specification. You can specify, for instance, that a particular attribute is a date attribute that specifies when the record should expire. This is a great way to do caching systems and generally clean up your database. And sometimes you may want to test this first before rolling it out. So LocalStack now supports this. You have to specifically enable this because it affects persistence. So we made this an opt-in flag. And you can also programmatically delete expired items. So LocalStack provides a sort of backdoor entry point, or rather backdoor API for DynamoDB, which allows you to programmatically delete all of the expired items. So this will be useful for you if you're testing time to live in DynamoDB. Another smaller feature we added to SQS recently is dead letter queue redrive. So in last summer, AWS added a feature to SQS which allowed you to perform the dead letter queue redrive, which means programmatically moving messages from a dead letter queue into a recovery queue. This is very useful when you want to re-queue dead letter events back into the original queue or maybe into a recovery queue to analyze the events. And LocalStack now supports this via the message move task API. So you can configure a dead letter a queue redrive policy as you were able to do it before. And now with the DLQ redrive, you can invoke start message move task and asynchronously move all of the messages from one queue into another. Then some bigger changes. We have a completely re-implemented CloudWatch. So we were depending on a third-party system previously, and now we've completely natively rewritten CloudWatch in LocalStack. So this brings numerous improvements, including parity, and we also now have an SQLite-based storage engine. Previously, our CloudWatch implementation would store everything in memory, and that was an issue for longer-running LocalStack instance. It was also a performance issue because every time we queried CloudWatch, we had to go through the entire in-memory database. And now with this SQLite-based storage engine, there are a bunch of performance improvements, both in terms of memory usage, but also query performance. We're releasing this as a preview, so it's still feature flagged, but you can activate it by using the conflict flag that's on the slides. Additionally, we also added Lambda alarm targets. So if you're using CloudWatch alarms, if you're testing CloudWatch alarms, let's say you have a particular metric and a threshold-based alarm that should fire when a metric hits a specific target. Previously, you were able to fire SNS messages or SQS messages, and now you're also able to directly invoke Lambdas. Another big feature we added is event bridge pipes. So this is a completely new feature currently in alpha version. So it's an initial preview version of sort of the basic set of features. So you can do pipe management, so basic CRUD operations for pipes work. We have emulation for SQS and Kinesis event sources. So if you're using SQS or Kinesis inside localstack, then you'll be able to trigger event bridge pipes using those event sources. We have some basic filter patterns implemented, and you can use lambdas for enriching events before moving them into targets. And currently, we also have SQS and Kinesis targets implemented. So please give this a try. Again, it's very early stage, but feedback would be very much appreciated on this. And we plan to extend both the event sources and the event targets with additional services that are implemented in localstack, including DynamoDB streams, Kafka, and so on. And finally, one big new addition is MemoryDB for Redis. So we have initial support for MemoryDB. There is basic CRUD support for cluster security groups, all of that, and we have a full cluster creation emulation. So when you create clusters with multiple replication groups and shards, we will create a Redis cluster for you, configure it, and then you can use your Redis tooling to connect to that cluster completely transparently. And this is my segue also into the tech demos, because now I will go into a little bit of the details of MemoryDB, how we changed ElastiCache to sort of set up for MemoryDB, and get a nice tech demo from Silvio. So happy to hand over to Silvio for the tech demo. And there you go.
So I'll be talking about how we reworked our internal Redis setup for both ElastiCache and MemoryDB. As you might know, for 3.0, so not this release, but the previous one, we rewrote the entire ElastiCache provider. We changed how we are dealing with. Okay, something didn't work here. We changed how we deal with Redis clusters in the background by adding a separate control plane, which manages the Redis clusters to start the nodes and to manually set how the cluster is configured so that it matches how ElastiCache does it internally. This is because ElastiCache has like two modes. It has the memcached mode and the Redis mode, and this whole naming of the cache clusters is a bit confusing. So I guess before we had maybe a bit issues, and those are like with this rewrite, because a cache cluster in ElastiCache is not necessarily a Redis cluster. It can just be a single Redis node. So as you can see in this graphic here, there's like different modes of how a ElastiCache cache cluster can look like. For example, there's like this Redis replication group, which just produces the replications of a single Redis node. So you don't have any sharding, but there's then also the cluster mode where you have the sharding. Rewriting this really helped us to get like a good basis to further work on our ElastiCache implementation and our internal Redis management, which helped us to extend it a bit to also have a container mode, which is something which is new for the 3.1 release. So now you can just set Redis container mode to 1, and instead of launching your Redis cluster inside of separate processes inside the main local stack container, if you run it in container mode, which I guess you do, you instead have a single container for every single node in the cluster, which you start for ElastiCache. So this gives many new benefits, which were also asked by the community and our users. So you can now use different Redis versions than is available inside of the local stack container. You can give any version that you want. Also, now we properly should use the default version, which AWS also uses. So we have an increased parity there. Another benefit of this is also that if you have like separate containers and want to debug what's happening on my cluster nodes, you can just look into the different logs which all of the nodes have, all of the Redis nodes have inside of a Redis cluster. Then, because we like updated this entire ElastiCache work, ElastiCache provider from the inside and how it works, it was not so difficult for us to extend it to another Redis-based service which AWS offers, MemoryDB. So at first, like, why does AWS offer two different managed Redis services? Which is what I asked myself at first when we looked into that. So what's with MemoryDB is meant to be really used as a database on like nodes with really huge amount of memory, like terabytes, and it's meant to be a really quick and fast database, and to have like a really simple application architecture. And ElastiCache, as also the name suggests, is meant to be used in combination with other databases. So you have a cache in front of another database where you can speed up your access times to things that you have stored in your database. So this, nevertheless, like even if they like are meant for different purposes, the internals are very similar. Also, like a bit like the API itself is also a bit similar between MemoryDB and ElastiCache. It's not exactly the same. The naming is different because MemoryDB is only meant for Redis, and ElastiCache has this whole memcached and Redis engine difference mode. But we were still able to utilize things which we used from ElastiCache and MemoryDB, and this led us to add this MemoryDB provider. And what's the whole reason to have like a local MemoryDB? It's just a managed Redis. You could also just launch Redis yourself or just use AWS. So the benefit of not launching just normal Redis clusters, it maybe won't be exactly like AWS does it. And the problem with AWS is the testing of MemoryDB clusters inside of AWS is a bit cumbersome. So first of all, if you create a MemoryDB cluster on AWS, you can just easily access it from your local machine. You have to, if you want to do that, you have to do some very involved VPN setup. And the other option then is to launch an EC2 instance, then set up this EC2 instance to access Redis, like access the MemoryDB cluster. And then you also need to set up some security groups and so on. And this is like a bit complicated. So I can showcase the difference between working with AWS MemoryDB and the local one right now on my screen. So right now we on the left side we have Lazy Docker. It's a really nice tool to look into what's happening in Docker right now for your machine. And on the right side we'll look what happens when we do it Redis MemoryDB work on AWS and on localstack. So first, let's start localstack, starting in the container in the background. So we have localstack running here. We can also look into AWS. We don't have any clusters running right now in AWS, but we can start one. If we create the cluster, let's call it demo time and small one because we don't want to spend that much money. And with 2 shards and a replica per shard. So it should start 4 nodes. If we do that, first have to wait a bit. Then we see that it's creating and takes quite some time. It's still creating. Instead, we can also just create the cluster in localstack. Looking at it, we immediately see that we launched 4 different containers for each of the nodes, and we can just look into the clusters that we created again. We see that it's already available, and we already have an endpoint, localhost at this port, which is one of the main nodes inside of the cluster. If you look at AWS, still creating. And then we can connect to this cluster because it's already available while AWS is still creating. We can see that the cluster is like working already. So we see that we have 4 nodes, two master nodes, 2 main nodes, and 2 replica nodes, as we've already defined. We can then also start, we see that we don't have anything in there. We can set a value like localstack. We say localstack is cool. We see that we have the localstack now. Then we have another key, maybe the community, since the community is awesome. We can set the community. We immediately see that the cluster works because the key slot of community. It was cluster key slot. Okay, cluster key slot community is 8,912, and the cluster key slot of localstack is 618. What this means with Redis clusters, it takes keys, then does some kind of magic hash slot, which then determines in which of the shards it needs to go. And as we can see here in the cluster nodes, we see that the first node has these slots, and the second one has these. And as we see, the community then should go into the second one, and localstack should go into the first one. What we can also see is that the AWS MemoryDB cluster is still creating. So looking into that, I guess you can see the many possibilities of using MemoryDB locally. You can easily just access it. It works. You have the cluster like you wanted it, and you don't have to wait as much, and you also don't have to pay as much money to AWS for that. So let's hop back to the slides. We can see that this was quite useful for us. We can see all the different logs from the different containers, which I sadly forgot to show. But with this lazy Docker setup, you can just switch between the containers and look at the logs and see what happens, how the cluster creation and syncing is working, and so on. And we've also seen that it works quite fast. You just have your cluster, you can do the Redis CLI, but also any other client, Redis client, which can just do this cluster connection thing. and it's much faster than AWS. And in the background, we also have this this implementation being like quite extensible. It's like most of our other implementations, you can add new features quite easily. So looking into the future, there's many things which we can add, which AWS supports, is like some automatic failover and snapshotting and scaling of the different cluster shards and so on. And of course, like for the security aspects, we can add the SSL support as we have with other services, and users and passwords, which is a Redis feature. And of course, the main benefit of using MemoryDB instead of some self-hosted Redis is service integrations, which we'll also can look into in the future quite easily, to connect MemoryDB with our other service offerings. So this is a short presentation of what's nice with using MemoryDB with localstack, and can hand over now. I think you're muted, Nancy.
Oh, thank you so much, Silvio. That happens, I mean, in the live streams. But no worries. I mean, that was an amazing demo. Thank you so much, Silvio. Definitely amazing possibilities. So with that, we have Q&A, and we have Thomas as well. So we can begin with the first one. Someone asked that, is there any docs on which services are mocked versus emulated?
Yes, great question. In fact, we do. On the docs page there, under user guides, we have a highlight page called feature coverage. And there you actually have a table where for each service, in fact, for each API operation, you can see whether it's CRUD, basic mock, or emulation. So yes, we're continuing to evolve that. And please give it a go and see whether that answers any questions you have.
Awesome. So with that, now let's move to the next question. Which APIs are available for MemoryDB? Any docs for that?
So you can look into the docs page of localstack, like docs.localstack.cloud. Currently, we mainly support the cluster creation and deletion aspect of MemoryDB. But since it's a new service, it's not fully featured yet. But feel free to add some feature requests on GitHub issues and so on, to what kinds of features from MemoryDB you would like, and I'm quite sure we can edit in a timely manner.
Awesome, thank you. And we can also paste the link of docs in the YouTube comments. So with that, okay, this is cool. I mean, so we just released 3.1, but people are already expecting to see new things in 3.2. So what can we expect?
Yeah, I would encourage also the community to answer that question for themselves and tell us what they expect for the next minor release. We're happy to listen to the community to understand what are their needs. Are they missing particular services? Are they missing parity for particular services, or whatever else? So GitHub is a great way, or Discuss forum for us to receive feedback of that sort, and based on that, we often put roadmaps together. That said, there's currently not a concrete roadmap for 3.2. Some of the things that I can tell that we're working on are the database migration service. So that will perhaps be in a preview phase, at least for 3.2. We're working on general improvements on our compute layer. That includes ECS and EKS. And also a way to make it easier to run localstack on different container runtime platforms. So running localstack on Kubernetes, for instance, works, but still with some quirks, and we're trying to make that easier. So this whole container and compute layer will see significant improvements over the next few weeks, which will also likely be part of the next minor release.
Awesome. So we already have someone with the request. Would love to see some ML Gen AI services, Bedrock, for example.
Awesome. So Silvio has actually worked on SageMaker. So we have SageMaker service and SageMaker inference service as well, right? You can serve models. Maybe you can tell us a little bit the details, Silvio.
So yeah, we have like the SageMaker inference. We have an implementation of SageMaker training jobs as well, but I think we need to rework this a bit more to be like more better in line with the inference. But basically, the inference works very similarly to what SageMaker itself already offers. This SageMaker SDK, which offers SageMaker Local, which basically provides the containers in which the inference jobs run also locally, and we utilize those to offer SageMaker inference inside of the separate containers, which are basically the same ones that are also used in AWS itself. I think currently we mostly support the PyTorch jobs, but I think it's very easy to add TensorFlow and so on later on. And of course, we can add any other thing that you might need from SageMaker. It's a really big API. We have this update thing where you can see what are the changes of the APIs, and SageMaker always, like every time they add something new, and it's like a huge API. But yeah. We can look into that.
I also want to add one last thing, namely that we're working on 2 extensions right now. So one is an OpenAI mock. So that's almost ready for merging. So if you haven't looked into LocalStack extensions yet, I encourage you to do that. You can find details and use guides in our documentation. So we'll have one extension that allows you to mock OpenAI responses, including like text token generation. And we also have one extension in the making using local AI, so we'll actually be able to emulate real generative models. So definitely keep an eye open for ML and generative AI services moving forward.
Yeah. I also wanted to add that because Silvio talked about SageMaker, we also have the application in Developer Hub, which you can find on our docs. So it will just help you to get started or just see the implementation. And we also have the video for the same. So wow, I love these comments. So nice work. Glad to see how far the tool has come ahead. Thomas, would you like to say something on this?
Thanks so much. We appreciate that people like the product. And yes, I do agree. We've come a long way and we're continuously improving LocalStack. So it's just going to get better over time.
Yeah. Thank you so much. I think with this, maybe we can move to the next talk. Awesome. So so we have the next talk by Chiche, and he's basically he's a network and systems engineer and AWS community builder. He has been constantly advocating about LocalStack, and he has been educating the community around cloud technology, and that's what he's going to talk about today. So with that, Chiche, over to you. Thank you so much.
Thank you. Okay. Thank you for this opportunity. I'm really glad to be here today to share about something that really matters to me, which is community and technology. So like Nancy earlier said, well, I kind of discovered LocalStack very late. I'm really surprised to see that LocalStack has been there for over 7 years now. So I discovered it, I think, just last year, and it was out due to, I found out about it due to challenges that we're facing in our community. And once we found out LocalStack, things really picked up for us. So today I'm here to share about my experience with that. Last year, I kind of gave a similar talk in the AWS Summit on LocalStack, and it was really welcomed by the community. A lot of people got to learn about what local stack was and how effectively they can use it. So I'm hoping that today I'm still going to share a similar experience, and by the end of this presentation, you'll be able to go ahead and implement local stack and maybe build on it and share a lot, share with us what you've been able to build with local stack. Without saying much, we'll have a brief introduction today. Then I'm going to talk about the story of the community leader. I'll talk about our infrastructure, a new approach, then local stack deep dive, which there's a video that will be shared if you are interested in seeing how local stack is being installed and test. You can go ahead and watch the video. So who am I? I'm Chiche. I'm a network engineer. When I always say network engineer, a lot of people always ask me like, what are network engineers doing with development now? So one thing that I really love is learning. So, and each time I learn and I found out something new, and it really, I enjoy sharing it. So on a day-to-day basis, I write a lot of scripts to configure networks, but on my free time, I do a lot of other stuff that I share with the community. So I'm also a community builder. I'm a user group leader, and I have a web hosting service that I currently run. So so what's the story behind all this? At first, I've always been that type of person who is very reserved. When I got into tech, working as a network engineer, there's not much to talk about. But 2021, when I got into cloud through a community, and I discovered that learning through a community is very, very impressive. It helps you grow, and there are a lot of things that you are able to achieve when you are in a community. So with that, I decided to get into community as well and started doing a lot of community work. And one thing I love about community is that once you are in a community and you are a leader in that community, it brings a lot of respect. But there's also a lot of challenges that you are going to have as a community leader. You're going to have challenges with figuring out what people really want, because not everybody likes talking. And as well as people will look up to you to provide solutions to every problem they are facing. So with that, I just enjoy the fact that community has always been something that really, really helps people to grow in their tech careers. So each time I join a community, I always endeavor to like bring that same community back home. And that is what made me to create the AWS user group for my local community, as well as HashiCorp user group and OpenStack user group. So I'm also involved with so many other user groups. So, but what is community really all about? Community is all about sharing knowledge. It's all about networking. It's all about learning, and it's all about growth. So once you are a community leader, or once you are in a community, you have to embody all this. You have to learn how to share. You have to learn how to network. You have to learn how to collaborate with people so all of us can grow, because we won't want that someone should be in a community and it's not, he at the end of the year is not able to achieve their goals. So my goal then as a community leader is to see that everyone is engaging with the community content. The community is collaborative. It's everyone is able to achieve their career goals, and at the same time, the space is safe for everyone to contribute and feel comfortable talking. So in order for me to keep the community really engaged, there's a need for everyone to be engaged. There's a need for everyone to be part of the community. So once you start talking about everyone being part of the community, now it comes a very, very big question of how can we get everyone to engage and collaborate during our events and in the community. Because, you know, during events, especially when you are doing workshops, you are hoping that everybody should be able to engage with that workshop. Everybody should be able to participate with that workshop. But before we dive into how we answer that question, it's good for you to understand our demographics here. I'm from Cameroon, and we have very, very young developers, and access to credit cards is a huge problem to us. We have a lot of youths that don't even have credit cards. They don't even have access to internet at all times. Some of us do have access, but not everybody is opportune to have access at every time. So during events, we always try to provide internet access to everyone, but we can't provide credit cards to everyone to create accounts and learn about different technological stuff. And even for those that has been able to create the accounts, maybe poor management with accounts and they have not been able to pay their bills and their accounts get suspended. So you find it that during community events, very, very little amount of people are able to contribute to those workshops because those are the ones that have access. A huge majority don't have access. So this has actually been a very huge burden to us. Like most of community leaders around us shared similar problems, and we have always been like, how can we go about solving that problem of credit cards, internet access, and account management? That is when we started looking out for a new approach where we can be able to emulate cloud services without necessarily getting into the cloud. And while we were in the search for that, we came across LocalStack, which is an open source tool designed to create local environments that emulate core functionalities of AWS services. It allows developers to build, test, and experiment applications online without the need for cloud resources or internet connection. Immediately, I learned about doing this offline. I was so happy, and immediately I got hooked up with LocalStack. So basically, we are able to create a lab. We are able to do a lab. Let's just say we want to do a workshop on hosting your website on AWS. We are able to do that same lab as if we are on AWS, but without AWS. So it was so amazing understanding that we can be able to emulate some core AWS services without necessarily having AWS accounts. So, and the process, it was so straightforward to get this working. And immediately we started testing out different workshops with LocalStack. So as you can see, this is on your left side of your screen, you see the AWS management console. And on the right side, you see the LocalStack resource browser. Once you have LocalStack installed and configured perfectly, you should be able to have your resource browser where you can see status of all the services that are running. You can deploy the services and do a lot of stuff with that from your resource browser. So so now we are going to get into the part of installing LocalStack. It's very, very straightforward to have LocalStack installed, and their documentation is so excellent. I really encourage everyone to check out their documentation. It's really well written and documented. So you can check out their documentation and see how LocalStack is being installed, whether you're using Windows, Mac, or Linux. From there, you'll be able to see how LocalStack is being installed. But there are different procedures to do that. For me, I prefer using Docker containers because it's quite easy and very portable for me. I can use it everywhere, and at any time I just spin up the container and use. So I prefer the step using Docker container and Docker Compose to install LocalStack. So there's a video that will be going on in the channel where you can get to that video. You will see the procedure of how I went about installing LocalStack. And it's just about, before I started installing, I had to verify if my containers is installed, Docker is installed, and if there are any containers running. And you create the Docker Compose file. And once you create the Docker Compose file, you have to grab the Docker Compose content from the documentation, and it just specifies you the various ports, the environment, specify the volumes. And once you get that file and paste it on your Docker Compose, you just need to run it, and it downloads and install a LocalStack on your computer. So once that is done, you can check out the various services that are running using that command, using that link. It's you paste it on your browser. Since you're working on your local host, it's going to show you everything that is currently running. So once that is done, yeah, you can tap yourself on the back and be happy you have your own AWS cloud. Let me say your own AWS environment installed right on your personal computer, where you can do all your various tests. You can do a whole lot of things with it. So if to push it a little bit further, you can create your S3 buckets with localstack. You can create your S3 buckets with localstack and test how it's working. So everything is being detailed out in the video, but like I said, that's the command to create your S3 bucket. It's just like you do it on AWS. Like if you know how the AWS CLI functions, localstack comes with a wrapper around the AWS CLI, which permits you to type commands easily. So you can type such a command and you've already created your S3 bucket, and you can verify the status of the bucket. And yeah, that's the end of the presentation. But what I just want to let you know is with the announcement of new local stack services, there are a whole lot of things that you can do with local stack. And if your community had similar challenges with us, like the ones we have, you had internet problems, you had the lack of credit cards, you can go ahead and use localstack to do most of the workshops, to do most of the AWS workshops. You can go ahead and create your own workshops with localstack, and it really helps the community to engage, in the sense that everybody now has the possibility to have their own localstack on their computers running, and they are able to test different environments. So without saying much, if there's any question, I'll be glad to answer that.
Awesome. Thank you so much, TJ. I think for the demo video, you have a YouTube video, right? So maybe we can paste that. Okay,
Yeah.
it's already pasted in the comment section. So basically, TJ has the demo, which everyone can see. So that was really nice, TJ. And the story which I mean, it's quite inspiring. And I'm glad that you were able to educate the community about the cloud applications through localstack, and this is really nice. So we have a question. Does localstack support local community builders? Hmm.
I think that will go to the local stack administrators. But
Yeah.
what I want to say is I'm an AWS community builder, and I'm just exploring how I can use localstack to better make people in my community understand AWS concepts. Because if I'm able to do an EC2 on localstack and explain to them how it works, and make them understand how EC2 functions, when they'll have access to their credit cards and be able to create AWS accounts, they can go ahead and create their AWS EC2 instance, and it's exactly the same thing. You can do the same type of API calls you do on AWS with localstack. The magic is you just have it running on your local computer, and it's just faster, and it's just like you saw the Siri presented. It's very fast. You there's no lag. Like during workshop events, like at times internet can be sluggish and you are not able to do some service work with some services on AWS. But when you're using things like localstack, such problems you don't have, and it's basically the same. So if you are an AWS community builder, you can go ahead and do your demos on localstack. Maybe the administrators of localstack will definitely create a localstack community builders program. Nobody knows.
Yeah. Yeah, I was just going to add to that. So we really love community, and so far, I mean, people like you, TJ, I mean, they're supporting us. So we would love to have community builder program. In fact, that's in the progress. With that, I would just like to ask if you are interested, if anyone in the viewers is interested, just ping us over Slack. If you would love to contribute, help, or advocate, then just let us know. We would love to have you as a community builder. So thank you so much, Iche. I mean, with this, I see. Okay, okay. There is one more thing. Thanks for sharing your experience. We'll try this out in my AWS UG. Awesome. You have just
Yeah,
inspired.
yeah.
Yeah, yeah.
Well, if you have any difficulties trying to go about it, you can always reach out to me. And I think on LinkedIn, you just type in Chiche, you'll be able to find me. So you can always reach out, and I'm always available to help as long as it's to do with community. I'm always available to help and share my knowledge of how I and others here we go about things. Yeah.
Yeah. Thank you so much. With that, Chiche, with that, we come to end. So yeah, with that, we come to an end. And I'm just going to share the community and resources. If someone is new who has joined us new, or maybe if you want to figure out, if you want to find out the new features in LocalStack, you can always check our video content. And you can also check LocalStack Developer Hub. I was mentioning earlier when Silvio mentioned about SageMaker. So you can find all those applications in our LocalStack Developer Hub, and you can find that on Docs. If you prefer the video style of learning things, then we have LocalStack Academy, where you can quickly go through the videos to learn about LocalStack. And we also have new module coming up. So thank you so much, everyone, for joining. I want to give special thanks to Harsh and Lazar, who are a part of DevRel team, and they were helping us backstage. I want to thank all the speakers for giving us the time with amazing demos, Thomas, Silvio, Chiche, and last but not the least, all the community. Thank you so much for joining us today.